Given the vector equation a plus b equals c, and that the components of each vector are a sub x is equal to 4 times y, a sub y is equal to 3, b sub x is equal to 0, b sub y is equal to x, c sub x is equal to 6, and c sub y is equal to 17, solve for the variables x and y as given. This is a kind of weird example. It's almost looks like something you might find in a math book, but I don't know if I've ever seen one exactly like this in a math book. I designed this example because I wanted us to get some practice with interpreting vector equations and getting results from them that kind of lend itself, in other words, a technique that lends itself to physics problems that are specifically where we're going to be going in this class and doing a lot of. So this is a very important skill. So really the thing to do with this is to recognize if I have the vector equation a vector plus b vector is equal to c vector, that means that the component equations will also be true. In other words, if I rewrite that equation but simply replace the vectors with x subscripts, this will be a true equation. And now what I can do is I have this whole set of substitutions given to me here, right? And the thing to recognize that's also a little weird about this is I've got x's and y's that are subscripts that are indicating respectively x and y components of vectors. But I've also got y variable and x variable in these, and that's a little weird, but they have a different meaning because these are like unknowns that I'm being asked to solve for in the sense of like an algebra problem that's just being presented in this weird way. So my next step is going to be to say, okay, replace each component with what is there. And a sub x is equal to 4 times y. Let me make that y look a tiny bit better. B sub x is equal to 0, so I can just put 0 in for that. And c sub x is equal to 6. So that means 4y is equal to 6, which I think anyone can see that if you divide both sides by 4, y would be equal to 6 divided by 4. 6 divided by 4, of course, is equal to 3 over 2, and as a decimal is equal to 1.5. So lo and behold, by looking at the x component equation, I have already solved for one of the two variables I've been asked for. Let's look now at the y component equation. And so in a similar way, again, the big theme for this topic we're in right now is if you have a vector equation, you can always write a component equation that looks the same, and you can do that for both horizontal and vertical components, both x and y. So now we're doing the vertical y components here, and now I can do the replacement. So since a sub y is equal to 3, b sub y is equal to the variable x, and again, it's a little weird that we're using variables x and y, and we're also using x and y's to mean horizontal and vertical, essentially. C sub y is equal to 17. Okay, and I'm going to solve for x, right? So maybe if I subtract 3 from both sides, right? I think we can do that. I would get, it looks like I would just get x is equal to 14, and I'd be done. I think that is my answer there. So in other words, the two answers, maybe just to make it clear that I think I've arrived at answers, these two numbers here respectively correspond to the answers for y and x. So let's go and check that with the answer on the slide. And it looks like, yeah, x is equal to 14 and y is equal to 1.5. So we got it.